Okay, this is the Math 1113 Zoom meeting for 8 in the morning, October 20th. And we'll just go over the assignments for this week first. There's going to be no quiz this week. We're going to cover section 6.5 and 6.6. And we have test 3 covering all of chapter 6 then on Friday, due Sunday. Practice problems for 6.5, page 546, problems 3 to 47 on. Section 6.6, page 558, problems 5 to 11 and 29 to 33. Just pick a few of them out. 6.6 is about harmonic motion, just a short section. Web assign, personal study plan, problem, I think we did all of them 1 to 9. And 6.6, just problem 1. Send me an email with a percent of these 10 problems that you get correct. Just give you an introduction to what's going on in 6.5. Basically, it's a review or more detail about inverse functions. Y equals arc sine of x, arc cosine of x, arc tangent of x. We've mentioned this before, but they give you another whole section about it. So they, page 542, we can argue this from the graphs now. I think they gave it to you way too earlier in the class. They hadn't shown you the graphs, but now they've shown you the graphs from graphs. Okay, so if you take y equals arc sine of x, domain negative infinity to infinity, make sure I'm in radian mode. I'm not. Radian mode, y equals sine of x, window, pretty standard window, graph, and you get your standard sine wave. Goes through the origin. I'll just remind you what we did earlier. There's a horizontal test or inverse, and it fails. Multiple horizontal line can only go through once to have an inverse. This is the x-axis. So we restrict the domain. The natural places cut it there and there. So we get version 2. Y equals sine of x. Domain. Turns out that is pi over 2 and negative pi over 2. Regraph that. Before it curls back on itself, thus failing, or curls up here, failing. That's pi over 2, negative pi over 2. If you're wondering how we know that, you're up here at 1. Got a negative 1. If you think on the circle, coordinate up here is 0, 1. Coordinate down here -1. Here you're at 1, 0. Remember, the y-coordinate is sine. So at angle 0, you're at 0, you're at pi over 2, you're at negative pi over 2. At angle 0, you're at 0. At angle pi over 2, you're up to 1. And when you go backwards around the circle, at negative pi over 2, you're down to -1. So you're looking at a domain minus pi over 2 to pi over 2, and that would be in brackets. This now passes the horizontal line test. Your range is -1 to 1 vertically. So y equals inverse sine. Remember, we would have domain -1 to 1, range minus pi over 2 to pi over 2. Remember, domain and range switch because you switched x and y. Find the inverse. And range switch. Okay, so this means arcsine of sine of x equals x for x in domain of sine. The inner sine, the inner one, that would be domain of sine minus pi over 2 to pi over 2. Spread it out. Use the interval notation. And sine of arcsine of x, x in domain of arcsine. And domain of arcsine is -1 to 1. All right, again, this gets very technical. So let's see if I've got it right. This is off page 542. You punch the keys in effect that order, sine to arcsine of x -1 to 1. Is that what I got? Yep. And arcsine of sine in that order, I've got it reversed minus pi over 2 to pi over 2, and that's what I've got there. Okay, let's try a couple examples right below. Example 1, part A, arcsine of 1/2. Okay. Basically, you can convert this to sine. Y equals arcsine of 1/2. Sine y equals sine of arcsine of 1/2. So sine of y is equal to 1/2. That's the arcsine. That number has got to be between -1 and 1, and it is. Okay, this is the angle. This is the y coordinate. Okay, we're using x's and y's because we're kind of in function letters, but maybe I could have used an angle letter. So I'm looking for find the angle with y coordinate a half. All right, if you remember around the circle, you get y coordinate a half at pi over 6. First kind of standard one up, pi over 6, your y coordinate comes up to a half. So this is equal arc sine of a half pi over 6. So without going through all of this rigmarole, this is the y coordinate on the circle, and your answer is the angle. Angle in range of arc sine. Now, on the calculator, if you punch arc sine of a half in radian mode, on calculator, radian mode, arc sine 1/2 is equal to, am I in radian mode? I am. Arc sine of 1/2, 0.5236. Pi over 6 is equal to, same thing. The calculator will give you the decimal and not the exact fraction on it. In degree mode, arc sine 1/2 did not switch to degree mode, sorry. Mode, degree mode, arc sine 1/2, 30 degrees, which is the degree equivalent to pi over 6. Okay, but we generally do these in radian mode, and they usually want the exact values off of the circle. And that's what they show you here. Arc sine of a half, pi over 6. All right, we try example 1b. Of negative a half. Again, that is the y coordinate because it's a sine or arc sine, and your answer is the angle. Angle, range, arc sine. You want to look at it on the circle, negative a half down here, you'd be at negative pi over 6, negative 30 degrees. And that is exactly what they get. And we froze. We're back. All right, so when they do example 1c, arc sine 3/2, this is a trick. If it'll catch up. If it'll catch up. may have to redo the share. Let me pause the recording. Get caught up. Domain. Arcsine was -1 to 1. Go back and put that back up. Yep, domain of arcsine. 3/2, 1.5 out of domain. It's not between -1 and 1. This is undefined. You got to be really careful about these things. And that's what they're saying here. 3/2 is greater than 1. It's not in the domain of arcsine. So this is not defined. You say undefined. Okay. Just compare, said arcsine of 1/2, we said was pi/6. You're looking for the y coordinate, angle whose y coordinate's 1/2, whose y coordinate is 1/2. Just compare to arc cosine. Now you're looking for the angle whose x coordinate. Cosine give you x coordinate. Its sine, the y coordinate, is 1/2. Well, if you remember on the circle, x coordinate 1/2, you're up at pi/3, or 60 degrees. But they'll want pi/3. And again, on the calculator, radian mode. Cosine 1/2. Oh, I mean degree mode Persian. Degree mode, you get 60 degrees. Radian mode, our cosine of 1/2, 1.047. And pi divided by 3, 1.047, same thing. Okay, I won't compare it to a tangent. You can't do tangent of 1/2. It's not a standard value. That's the basic idea. I won't go through all of the details, but they do arc cosine, page 544. Cosine of arc cosine of x, x minus 1, that's equal to 1. And arc cosine of cosine x, and that is between minus 0 to pi. Sorry. 0 less than or equal to pi. And that is because cosine is doing this, and they cut it from 0 to pi. I'm sorry, that's not pi. It's pi down here, my fault. Pi. So they're doing this, 0 to pi. So like example 4a, arc cosine of √3/2. This is the x coordinate angle with x coordinate √3/2 on 0 to pi. top half circle. Arc sine is right half circle. Which is -1 to 1. All right, so where was the x-coordinate √3/2? That was at pi/6. This is equal to pi/6. Okay. Inverse tangent. Page 545. And I'll just give them to you. Tangent of arctangent x, and that is all x, or why is it getting to infinity? Book says real numbers. You can stick anything into an arctangent. But if you go arctangent of tangent x, that is between -pi/2 less than x less than pi/2, because you're blowing up at the pi/2, so it can't be equal to. For tangent, you are taking minus, but you can't be equal to -pi/2 or pi/2. Your domain is there. That's what they're showing you here. So they give you something like example 6a. Arctangent of 1. Now remember, tangent is ratio y over x. So you're looking for the angle with ratio, with y to x ratio equal 1. Well, if you look on the circle, tangent value of 1 occurred at the coordinate √2/2, and that was at pi/4. This is equal to pi/4, or 45 degrees. This makes perfect sense to me. All right, they also talk about inverse secant, cosecant, and cotangent, and we're not going to mess with those. So to try to get to some example problems here. Page 546. This is the 6.5 homework. Say try 3b, and arc sine √3/2. Right, that is your y coordinate, because it's a sine. I want to find the angle with y coordinate √3/2. No, it's 60 degrees at pi/3. You're up here at √3/2. Your long side is √3/2. This would be pi/3. You're really looking on the right half circle. Find the angle on right half circle. Sine, arcsine, and arctangent go right half circle, and cosine goes top half circle. If I write that down, arcsine, arctangent, top half circle, and arc cosine. Do it right. Right half circle. And the arc cosine is the top half circle. Where's a tricky one? Maybe a tricky, I don't spot a tricky one where they're going out of them. Okay, 4C there. Okay, well, 3C. An arc sine of 2. This is out of domain. So this is undefined. There is no y coordinate on the unit circle. There's no y coordinate of 2 on the unit circle. If you punch it, second sine of 2, error domain error. But that's a signal on the calculator, it's telling you that. All right, well, punching the inverse trigs with the calculator should be pretty straightforward. Okay, and then they start mixing them up. So say 11, this should be real straightforward, an arc sine of 2/3. See, you got to check between -1 to 1. So this is good. This is legal. Do a second sine of 2/3. You're at 0.73. We'll call it 0.73 radians. You know what that means. It means that you've got a y coordinate of 2/3 and your angle is 0.73 radians. If you punch it in degree mode, second sine 2/3. I saw that. I switched it to degree mode, so second sine 2/3. You're 41.81 radians. I'm sorry, 41.81 degrees. If you converted 41.81 degrees times pi over 180 degrees, your degrees cancel, so multiply. Gee, what do you think I'm going to get? Times pi divided by 180. Here's my 7.73 radians. But this is still the y coordinate. And your calculator is programmed to give you an angle. 0.73 radians. Calculator is programmed to give an answer in the right half circle. Which would be from minus pi over 2. On arc sine, be less than or equal to x, less or equal to pi over 2. Arc tangent, you take off the over equals. Okay. Go down to something like 23, and they're doing both of them a sine of an arc sine of 1/4. Sorry about that. It said 1/4. Oh, that's an arc. So that, yeah, it is a negative arc sine. Okay. Tough morning. Sine of an arc sine of 1/4. There we are. All right. All you got to do is check in domain of arc sine -1 to 1. Yes. This is 1/4. This is legal. And these undo, and you get your, in effect, x 1/4. Okay, let me see if I can spot something that's nastier. 26. Sine of an arc sine of 5. See, what happens is people will come along and do this, and 1/4. So a sine of an arcsine of 5 must be equal to 5. No, 5 not in domain of arcsine. This is undefined. You can punch these and correct them on the first one. Sine of arcsine 1/4, 0.25, which is 1/4. Sine on the second one, sine of arcsine of 5, out of domain. It's not 5. So you really got to watch for this. Okay, so what happens if you switch it up? See, the same thing's going to happen on arcsine of sine of 3 pi over 4. All right, so let's see. Let's switch it up. Well, let's try. Okay, 33. Arcsine of sine over 4. Okay, this is second quadrant. Okay, it is not 3 pi over 4. But it's not undefined either. All right, what you can do is work this out. Sine 3 pi over 4 is going to be the y coordinate 3 pi over 4 will be root 2 over 2. 3 pi over 4, you're at the pi over 4 equivalent. Coordinates are negative root 2 over 2 on the x, but positive root 2 over 2 on the y. And so your sine is positive root 2 over 2. So now you sub in root 2 over 2 for this, and you want an arcsine of root 2 over 2, and that will be equal to pi over 4. Because now you're looking for, this is 0.707, so it's in domain. This is legal. The angle on the right half circle would be pi over 4. And you can punch this on the calculator. Spell calculator. An arcsine of a sine of 3 pi divided by 4 I didn't show what I wanted to show. What mode am I in? I'm in degree mode. Yes. I'm in degree. Wrong mode. My apologies. Shoo. Okay. Mode. Thought all my years of trigonometry are out the window there. I'm in degree mode. Okay. I'm sorry. Switch it to radian mode. So now arcsine of sine of 3 pi divided by 4 comes at 0.785. 8539. And pi over 4, same thing, which is equal to pi over 4. Shoo. Thought all my years of trigonometry were out the window. You got to really be watching careful that you're in the right mode. You want to be in radian mode. Okay. What happens if you switch things up like 43? A tangent of an arcsine of a half. Okay, I would work it this way. Your sine, arc sine, I know it's the sine, but it works like the sine. Opposite over hypotenuse. Opposite's 1. The angle here, this is the angle. Hypotenuse is 2. You could do 1/2 of the circle of 1, but then you got a nasty fraction. I'd rather just play it over hypotenuse. All right. So you want to call this x. You got x squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. X squared equals 3 because you subtract 1 over, and x would be the square root of 3. So this is equal to square root of 3. And your tangent is opposite over adjacent. This is equal to 1 over the square root of 3. Opposite, adjacent. They probably rationalize it for the book, although you don't have to for me, but book will probably rationalize root 3 over root 3 and call it root 3 over 3. All right, let's see if that's the form they use. This is 6543. 6543. Root 3 over 3 is what they do. Yeah. Let's see it. 43, section 6543, root 3 over 3. Okay, I will let you all work on those. And we'll quick intro to 6.6. It's called modeling harmonic motion. Okay, and they show this, page 548, with springs. And waves. I take a spring, put a weight, and I pull down and let it go. It will bob up and down. Bob up and down. And if you track it and graph its motion, they're showing you this. If you push it up, I guess if they're, or maybe they're pulling it up, but it goes up, then the spring stretches down, then it stretches down to some maximum value that the spring will stretch to, and then it goes back up again. And it follows, if you track that through, following a sine wave. Electricity follows these kinds of waves. I could put a meter on your outlet and on the meter show you these kind of waves. Your heart has electrical signals that show these kind of waves. If you watch medical shows and they zero in on the heart meter, some poor guy's in a stretcher, bed with heart problems, and they're monitoring his heart. You will see these kind of, this is really a simple one, and, a real heart one, it's jumping up and down. So we've really kind of simplified it to one wave. So they're going to use the formulas A sine, and they use a WT. It looks like a W. It's called an omega. I can't make the fancy script on it. Y equals A, or cosine of T. All right, and if we reach back, your amplitude will be the absolute value on that A, the coefficient, in both cases. The period, remember back earlier we called this K, but it'll be 2 pi over that W, 2 pi over K. This is called KT back then, a couple sections ago. And so 2 pi over that. And then it turns out the frequency flips it upside down. Omega over 2 pi. All right, period is time for one cycle. And frequency is the number of cycles in 1 unit of time. Number of cycles in 1 second, really. So it's like cycles per second. This is like seconds per cycle, and this is cycles per second. This is like 1 cycle, 1 cycle. It's like miles per gallon versus gallons per mile. We're just going to pick out a few of these. We're going to worry about damped harmonic phase and phase difference, and we're not going to worry about you can track people on a Ferris wheel if you ever wanted to do it. You can track people's motion on a Ferris wheel. But we're just going to pick out a few of these and not mess with all of the details. So if you look on page 558, a given function models displacement, find amplitude, period, and frequency, and then sketch a graph. So number 5, this is for 6,6, equals 2 sine of 3t. They said find amplitude. This is A amplitude. That would be 2. Remember, it's the positive version of this, so if it's already positive, it's the same thing. Period. Remember, we're matching to A sine of this WT. Period. 2 pi over that W, which would be 2 pi over 3. Frequency. Flips it upside down, 3 over 2 pi. I'm sorry, it's not B and C. This is all A, my fault. And then part B is the graph. Radian mode. Equals 2 sine of 3x. We're using x for t. Graph. And you see it's going upside down. They say over 1 period. They probably usually mean on the positive side, so we'll just pull off 1 cycle, starting at the origin, and just pull off 1 cycle. And they're basically saying it's going up to 2. That's its amplitude. And 1 cycle here, this would be a 2 pi over 3. You don't have to label these things on the graph. And you get 3 over 2 pi cycles per second. And you're getting 2 pi over 3 seconds per cycle. That's about all there is to it. If I could pull back on that assignment. It's one of the section we were doing. Why have I mislaid my assignment? Oh, here it is. 29 to 33. Okay, down here. All right, so they want you to find 4 things: amplitude, period, phase. You don't really have to find phase. We're not going to mess with phase, and horizontal shift. You have 5 sine 2t minus pi over 2. Amplitude 5. Period. That would be the 2 pi over the 2, which would be pi. This is like your K or W. This is your amplitude A. Okay. Phase shift, if you remember, or horizontal, they're calling it horizontal shift. You want to write this with 5 sine, factor out the 2, t minus pi over, and put the 2 on bottom. And if you remember, you had the k factored out, they used an x back then minus, and so you'd be at pi over 4 here. Pi over 4. The horizontal shift would be pi over 4. You don't have to worry about phase. We'll just do amplitude period and horizontal shift. All right, that about ends our time. So I hope that helps you get started for this week. We will have one more Zoom meeting on Thursday. Friday at 8 o'clock, my fault. Friday at 8 o'clock. We will end the meeting.